What if you could actually understand the source code of the universe? I don't mean like in some dense, impossible textbook, but as one single, elegant story. Well, that's exactly what we're going to do. We're going to decode the rules of reality by looking at the three great pillars that hold up everything we see, from the tiniest particle to the biggest galaxy.
Because at its heart, that's what physics really is. It's not just a bunch of equations you have to memorize. It's a powerful way of thinking about the world. It's like putting on a special pair of glasses that lets you see the hidden architecture of everything, revealing all the patterns and probabilities that are secretly running the show.
All right, let's jump right in with our first pillar, fields and waves. I want you to think of this as the invisible stage where reality happens. It's this stuff that fills all of space and basically tells the fundamental forces of nature how to act.
So what exactly is a field? Well, imagine the temperature in a room. Every single point in that room, right, down to the millimeter, has a specific temperature. A field is just like that, but instead of temperature, it's holding the instructions for forces like gravity or electromagnetism. It's the invisible rulebook telling every particle where to go and what to do.
Okay, I know this slide looks a little intense, but don't worry, you don't need to solve these. This is the source code for all of electricity and magnetism, Maxwell's equations. Just focus on the last two. Faraday's law says a changing magnetic field makes an electric field. Then, the Ampere-Maxwell law says a changing electric field makes a magnetic one. See that? It's a two-way street, a feedback loop. And that little detail leads to something absolutely incredible.
And here's that idea in action. When you put those two rules together, the magnetic field making an electric one and vice versa, you get this beautiful, self-sustaining dance. It becomes a ripple that just keeps going, propagating through space forever.
So, the huge question is, how fast does this ripple travel? Well, when James Clerk Maxwell plugged in two numbers from his equations, just basic constants that describe electricity and magnetism in a vacuum, this is the number he got. And he realized immediately that's the speed of light. I mean, in that single moment, he discovered that light itself is nothing more than a ripple in the electromagnetic field. Physics was never the same again.
To make this a bit more concrete, let's compare it to a wave we all know, sound. As you can see, sound is a mechanical wave. It has to have something to travel through, like air or water. If you're in a vacuum, there's no sound. But light? It's an electromagnetic wave. It's a ripple in the fields themselves. It doesn't need a medium. It can travel through the total emptiness of space, which is, of course, why we can look up and see the stars.
So we've got the stage set. Now let's explore the rules of the play with our second pillar, energy and information. These are the laws that govern not just one particle, but huge systems. They're the universal rules of energy and, well, messiness that apply to absolutely everything.
These are the unbreakable laws of the cosmic economy. First law, energy is conserved, you can't make it from nothing, and you can't destroy it. You can only change its form. The second law, the total disorder or entropy of the universe is always going up. Things tend to get messier over time. And the third law, it basically says you can get really, really cold, but you can never actually reach absolute zero.
Now, we usually hear entropy described as just disorder, but it's so much deeper and cooler than that. It's really a measure of possibilities. Think of it like this. A brand new deck of cards has only one way to be in perfect order, but there are trillions upon trillions of ways for it to be shuffled. A shuffled deck is just way, way more probable. And that's all nature's doing. It's playing the odds, always moving towards the states that have the most possible ways to exist.
And this beautiful little formula, which is actually engraved on Ludwig Boltzmann's tombstone, is the bridge. It connects the microscopic world of possibilities, that's the omega symbol, to the big macroscopic world of heat and energy that we actually see and feel. This is where statistics and probability literally become physical reality.
Okay, so we have the stage, fields, we have the rules of the play, energy. Now let's meet the actors. Our third and final pillar is particles and symmetries. These are the fundamental building blocks of you, me, and everything else, and the deep, deep principles that keep them organized.
And here they are. This is pretty much the complete cast list for reality, according to what we call the standard model. You've got your quarks, which build protons and neutrons. You've got leptons, like the good old electron. And then you have bosons, which are the particles that carry the forces, like the photon, which is the particle of light. Everything you've ever touched is made from some combination of these guys. So we have all these particles, but why do they obey such strict rules? I mean, why is energy always conserved? Why is electric charge always conserved? It's not just some random cosmic rule. The answer is honestly one of the most profound ideas in all of science. The answer is something called Noether's theorem. The brilliant mathematician Emmy Noether figured out that these conservation laws, they aren't fundamental rules themselves. They're actually symptoms of something much deeper, the symmetries of our universe. They exist because the laws of physics don't change no matter how you look at them.
And this is where it all just clicks into place. Check this out. Because the laws of physics work the same today as they did yesterday, that's a symmetry in time, energy has to be conserved. Because the laws are the same here as they are on Mars, a symmetry in space, momentum has to be conserved. These aren't just arbitrary rules, they are the direct, unavoidable consequences of living in a consistent, symmetrical universe. So, let's pull back, let's bring all three of these pillars together and see the single, unified picture of physics that they create.
This quote really captures the whole spirit of the journey, doesn't it? The entire story of physics is about this drive for unification, finding a simpler, more beautiful, and more powerful description that ties everything together into one single cohesive truth.
So here it is, the ultimate takeaway. These pillars aren't separate ideas. They're all deeply interconnected. The particles, they're just ripples in the fields, and their interactions are governed by the laws of energy, which themselves pop out of the fundamental symmetries of those fields. It's all one story, one grand interconnected description of reality.
We've managed to write this incredible, unified code for the reality we can see and touch. But we know for a fact that the story isn't over. Big mysteries like dark matter and dark energy are out there, telling us that there are still pages left to write. So the real question is, what new pillars, what new fields or particles or symmetries will the next chapter of this amazing journey reveal?